Hello, everyone. Welcome to the masterclass. We're just gonna give 1 more minute to let people come in, and then we'll get started. This is gonna be a very busy and packed with information lesson. So hopefully you like it. So it's gonna be hands-on. So every masterclass that's done by Redpanda is going to be hands-on. So get ready to get some coding in action, right? So let me see how the time is. We are on a little bit of a time crunch because there's a lot of things that we need to cover today. So just kind of like wondering like where everybody's coming from today. Are you coming from US? Are you outside US? You know, just let me know where you are. Just put it in the chat. Love to see some chat going. I love to see your feedback right away. Yeah, just let me know what's going on. I am here in Boston, Massachusetts, and hopefully everybody's joining in the same, like not a crazy time that you have right there. Currently, you're about lunchtime. Awesome. Let's get started. So for the kind of like just kind of letting people know what this entire course is kind of targeting to. So this is a beginner level course. So we designed this course because I know a lot of people are new to this Redpanda Connect technology. So I think this course is designed for developers that's trying to get their foot in the door, trying to understand where, like trying to kind of get you started on for coding your first pipeline. So kind of going through some of the components inside the whole Redpanda Connect and understand what it is. So we will not be covering a lot of the DevOps side of the stories, and we'll not be covering a lot of the in-depth like observabilities. We'll not talk about deployment lifecycle. So if you're here for that kind of thing, you're not gonna get it in this particular class. But you know what? I love to hear your thoughts on what kind of classes that you want to you attend next time. Your feedback is always our best input, because I think I designed the courses just based on your feedback on what should we do next. If you don't tell me, I don't know what you want, so I'm just gonna do whatever I like. So it's best to give us some kind of things that you want to look for, like if you want to learn about how do I deploy in Kubernetes, and how do I deploy it in my VMs, and how do I scale it, those kind of things, let me know. I'd love to do that. I see a lot of people from Texas. Awesome. Did you all go to the Current? Because I was there. Yeah, so for those for masterclass, we like to keep this as interactive as possible. You can always go back and watch the recordings. We'll be recording this anyway. But the thing is, you don't get this chance of interacting with all the experts here. We get to answer your questions right away. So if you have any questions, do drop it down in the Q&A session. And if you have any comments, put it in the chat. Love to hear your comments. I also like, if you were confused about something, definitely put it out there. I'm happy to address that for you, right? So if you think you want to be, you want to learn more details on specific methods or specific way of how Redpanda Connect handles things, you can just put it out on chat or Q&A. Love to address that. And then make sure you put in your questions on the topic. So I will be talking about Redpanda Connect today. So that's not like dive into the details of like streamings and all that, right? So yeah. And then if your question is too specific, we'll do that later on. We'll talk to you about it afterwards. Love to chat with you like in our Slack community as well. So the session is recorded. We will be sharing that out, and then there is going to be a hands-on portion of the lab today. So you're going to get a link to the lab. So the reason why we do that in an environment is that we have control over, the whole versions of, things that you have that we can kind of look into the problem. So you're focusing on the program itself instead of, like figuring out the versions of your binary is or your environment problem. Let's just get rid of that first, learn the concept, and then the content is also available on the GitHub as well, so you're welcome to work that on your machines afterwards. But in this case, just work with us on an environment that we know it is going to work, and then focus learning Redpanda Connect at this moment. Just a quick note about serverless. So we do have a serverless platform. If you don't want to like spin up a Redpanda Connect or Redpanda cluster in your local environment. If you want to just have it running right away with a usage-based pricing, this is a great platform for you to go on. And I'm not sure like who came here because of the hackathon, but we are actually running a hackathon, and it's a virtual hackathon. We just started this Monday, so you get the whole 4 weeks of like, getting your hackathon project done. It's a very good, we have a lot of prizes. Like I think the first prize gets up to like the first prize gets up to $5,000, and like it's pretty good. And then you can use what you learned today, and then to explore on creating something fun. It's all about Redpanda Connect. It's all about how to integrate with AI. So feel free to take a look at it. Have fun. This is all about having fun while learning the technology. So join our hackathon, sign up, and then maybe work with somebody. If you don't have a partner, maybe ask around in chat. Like you might find some like teammates here, right? So best place to ask. And then there's a lot of resource that we provide. We provide like the university, the blogs, the code, the documentations. If you're doing Redpanda Connect, you're probably gonna have the documentations up all the time, right? So, well, I see somebody from Australia. Wow. Okay. Awesome. I used to study there, so love from people, love to the down unders. Yeah. All right. So before we start, I have a few poll questions to ask before we get started. This is going to help us on building the next set of the programs and what we want to do. So, what is your level of experiences with Redpanda? I just kind of want to learn like where you are at this moment. So, if you're here, if you know Redpanda already, then is this Redpanda thing new as well? Like, let us know in the chat. I'd love to know that. Oh, Angola, Italy. Getting people all over the world. I like that. Yeah, perfect. All right. So the presenter for today, I will be your main presenter, so you'll see my face a lot. And then we also have people helping. So all the experts helping: Dave, James, and Kurt, as well as Jeremy, who is not on this, but he will be helping as well, is all going to be our expert for today. So you can ask them basically any questions about Redpanda Connect. They're very knowledgeable. They can answer all the questions that you've got. So happy to definitely take this chance of asking. Argentina. So we've got everybody from a different continent. This is awesome. All right. So let's look at the agenda for today. So we have like housekeepings, and then we'll get started. So I think we're gonna cover some basics. Looking at the polls right now, I see a lot of people who is just looking and they never heard about Redpanda before. So we're gonna do some kind of like overview of what Redpanda Connect is, and then we'll dive into data transforms. That's where people having the most problem. We're not gonna go over every single one of the components in Redpanda Connect, because I think it's just how you configure it differently, right? So they look at the documentations, but what we will be focusing on is data transformations and how to use Bloblang, how to use that to transform your data when you're trying to build a data pipeline. So we'll be using most of that, module 2 and module 3. Module 2 is more basic, understanding the syntax of Bloblang, and module 3 will be doing some kind of more advanced work on data enrichment, talking to external endpoints, and all that. So awesome. Perfect. And then last but not least, we'll talk about like some AI use cases. In case that you came from the hackathon community, you want to learn about how Redpanda uses AI, that's what we're going to cover. Second poll, just to keep you engaged so you don't lose your attention. So what are you currently using to stream your data? Just let us know what they are. And yeah, so I think while we're asking you for these questions, we're going to cover a little bit about Redpanda. So I think I said this like 4 million times already, but I think most of you probably know already, but we are a replacement for Kafka, but a much simpler versions of Kafka. So we take out a lot of the virtualizations. Basically, Kafka uses JVM because it's written in Java and Ruby, so that it relies on JVM. So we took that out. You don't need it anymore because we wrote everything in C++. And then we took out the virtualization in the operating system layer where we directly talk to the disk. So without that particular, all that virtualization layer gone, everything is a lot simpler. So you don't have to tune as much as you have to do with Kafka. So, basically it's just much easier to configure and manage. And then we also there's a lot of hanging pieces when you try to start up like Kafka's, like, schema registries and HTTP proxies, they're just kind of bits and pieces you have to install outside of Kafka. But we got it all together with Redpanda. So with that single binary, you got everything and it just works. But other than that platform that we're proud of, that does streaming, that is very fast, very performant. We recently acquired Benthos, which is the product, which is why you're here today, that allows us to get data in and out of different data sources, like databases, data lakes, and data warehouse and different services. This is like the pipeline, the ETL pipeline that allows you to connect your data and then building that data movement throughout your system, right? Another thing that came out 3 weeks ago is Redpanda 1. I don't know if you heard about that before, but since you're here, we're just gonna talk a little bit about what is Redpanda 1, right? What is that? So like we're all getting data coming from Redpanda Connect, and it all gets streamed into Redpanda. And one of the things about Kafka and Redpanda is all about low latencies because we're dealing with data in real time. So we're constantly streaming data from external sources into our platform. So in order to get that best latencies and all that, we have to store the data somewhere, right? And currently we're storing everything into a disk. But we know disk has limitations. There's no finite amount of storage for your disks. So therefore we need to set some kind of retention limits, right? So if my data exceeds for 7 days, then I'm gonna just like delete it out so I have enough space in my disk to serve other data, right? So that's kind of the mentalities of how Kafka works. But some people want to keep those data because they might be important for other things and all that kind of different things. So that's why we have tier storage where we're moving all this deleted or unretained data over to the object store because object store compared to a disk is a lot cheaper. So that's why we're kind of offloading it to offloading it to object store. That's good, right? But sometimes we don't even need a disk. If people wanted to have services, they're not that, performance sensitive. They were saying that instead of like having a disk, which is probably gonna cost a little bit more than compared to, directly having it stored in the object store, can we just have the data stored in object store? So now we have like in Redpanda 1, we have an option for you to actually get data stored directly into object store. And because of how object store, like, Azure Blob, Google Cloud Storage, and your most familiar S3 object store, I think they would allow you to do some kind of replication across regions. So you will be able to kind of replicate your work across different multiple regions. Therefore, it's easier to so you can focus on just writing to a streaming platform where everything will be do that as well. And then sometimes when we were working with all this data, so now we're storing everything into the object store. Now we're storing everything in there. What's the point of storing it there? Are we just gonna reuse it by reconsuming it? Is that what people are using it for? No, like a lot of people wants to use this data for big data and analytics, right? People wants to use that for large volume data, batching, processing, big queries and all that kind of stuff. So and then because of that, people has different data format demands, right? Because most of the time when you're dealing with large data processing, like bigger volume of data, you don't want to store data in a role-based type of format. You want to store them into you want to store them in some kind of a column type format, right? So it will save a lot of spaces, a lot of things, right? And then to do that, you also, and because of that, those data are like, deployed and then stored in the data store. How do we find them? So Iceberg become a very popular standard for these type of processing engines, right? So if we can store these data into the storage and also supports the format that these tooling needs wouldn't that be the best? So we can get rid of a lot of, the databases and all that, just kind of directly have it. Since, streaming platform is the source of getting the data, why don't we just store that? And then instead of like, doing a lot of direct replications, I know a lot of people use Redpanda Connect to stream data over to object store because they can use that later for big data analytics. If we can do that directly in the platform, wouldn't that save a lot of time? So this is what's going on. So this is why Redpanda 1 becomes that, that source of truth for you to store the data. And I think what I really like about it is because it allows you to configure things in the topic level. So you can kind of, for instance, you can set your data into the disk. So if it's very latency sensitive, it's performance sensitive, you want to do it in a traditional way. If you wanted to replicate it across different regions, then you probably want to put it in directly into S3 object store. And then if you wanted to have it for big data analytics, then maybe storing that in iceberg format is good. So that's what Redpanda 1 is, and I hope you learned something about it today. This is something that we're pushing out, and then that's what's going on. So there's a question about, wouldn't it increase costs? Well, I mean, you're gonna have some costs dealing with all this big data anyway. So it depends on where you're spending the cost. And then if we can do that more efficiently without you replicating everything over, wouldn't that saving a lot more cost? I personally think it's a more cost saving way of doing things. All right, let's get started with what is Redpanda Connect. Redpanda Connect is a data pipeline streaming ETL tools that allows you to quickly get data from one point to the other. And then in the middle, you can do some kind of data transformations, data enrichment, and then maybe do some kind of filtering and validations to validate if the data is correct or filter out the things you don't want for those kind of things in between the different endpoints. That is what Redpanda Connect is for, right? It's like traditional like data pipeline, like what it does. But what is not about, it's pretty boring if you think about it. I don't know, like when I was creating this deck, I was like, what do I talk about? There's no fancy, like, how do you configure things? Like, it's not that hard. So it's a very single binary file. It's a single binary file. That's it. You don't have to add dependencies. You don't have to create an image to do that. You don't have to import all the libraries. It's just like a single binary. It will just work. All right, we're done. Easy, right? All right. So, but other than that, how do you tell Redpanda Connect what to do, right? Well, so your instructions of telling what Redpanda Connect what to do is written in the form of YAML file, right? So compared to what Kafka Connect does, Kafka Connect does configure things as well. They do it in more of a property setting base. So for me, it's kind of like, yeah, it does things, but like in the level of like clarity, I think YAML kind of shows things a little bit better, in my opinion. And also, when we're processing the data, it does process both structured and unstructured data, right? So if you're doing a lot of transformations, I assume you'll be dealing with structured data, and then when we're dealing with encryptions, decryptions, and we're dealing with like unstructured data, like binary codes. So the reason why it's a single binary is because it's written in Golang, right? So it's not written in Java, so you don't have that extra level of JVM that you could take care as well. So it's a single binary written in Go, compiled into binary, and that's kind of what it is, right? So you don't have to actually learn any programming language to use this tool. All you have to learn is how to configure the configuration to tell Redpanda Connect what to do. So that's kind of it, right? And it does provide a lot of like out-of-box observabilities. So if you're looking for, observing like what the metrics is, looking at the tracings and the loggings, it's already out there, right? You don't have to do it yourself. It's just it has an endpoint that already exports all the metrics that you need for it. And I think for me, the logging is amazing. Like you can just show the loggings. You can output the loggings into a topic, so you can, trace it. So that's like what's going on there, right? So what programming language supports for transformation? So currently in the syntax itself, we use something called Bloblang. It's our language for processing, but there are some processors that people do, especially if you look at Dave's repository. he has a processor that takes in Python, so you can do transformations using Python. And I think there is another one that's JavaScript as well, so you can use that. And the way that Redpanda Connect handles scaling is that you use Go routine to kind of handle the multi-threadings and all that. So you will be able to scale it out. And it's stateless. So it's one single process running, and then that's all you need to do. Like you don't have to spin up a cluster to make sure it works. It kind of just a very simple, like stateless process, and you just do RPK run and just run, right? That's what people likes about Redpanda Connect. And if you go onto Reddit, people were complaining about how like complex Kafka Connect is. People often ask you, have you heard about Benthos? And Benthos is Redpanda Connect. And just to emphasize on the simplicity side of the things, like the way you run it is using RPK. RPK is the tools that you download and then do RPK Connect, and then just do a run with your configuration file, and it will just work, right? So that's kind of it, right? So let's talk about Connect, right? So Connect configurations. Connect's configurations is composed of a couple of different configurations, components. The three main components that you will have to do, well, not have to, but at least you have to have input and output. You'll do is you have to configure inputs. That's where your source data is coming from. And then your output, that is where your sync data is. So this is where you're going to put your data to, like have your data written to. And in the middle is the processors. Processors is the place where you're going to process your data in the middle, doing your transformations, enrichments, and everything. So it looks kind of like this, right? So the inputs consumes things, and it could be multi-threaded, it could be in batch, depending on types of inputs that you have. In the case of this particular SFTP server, one single thread reading data into there. If you're thinking about Kafka, then Kafka have different partitions, so you probably have multiple threads like reading from different partitions as well. So it's just like depending on the inputs that you have. And then we have like pipelines and outputs. And outputs, we support switching, so you can output data into multiple different endpoints, and then in the middle you're just processing the data. And then other components that we have in Redpanda Connect is something that you have to you use often is error handling. How do you not write error handling like when you're doing stuff, right? So error handling, if you probably want to do your error handling right? So you want to do error handling, you want to make sure that you're retrying things if it's doesn't work, especially if you don't want to do like your AI, say if you want to using AI, you're trying to do like enrichment with other data, trying to like, so you can build a good reg use case where you're getting data externally. What happens if the external data failed? You probably want to do some kind of error handling before that goes right. So just kind of like error handling, just make sure that your programs like run smoothly. Bloblang, so like it's the default language that we use to process data transformations, right? Bufferings and caching, this is something that we use in order to support some kind of more complex data processing, right? Like buffering is for windowing, for batching. Caching is if you want to have a placeholder for your data in case that so to avoid constantly going back to the same endpoint asking for the same outputs, it's best to cache it somewhere, and caching just does that for you. And observability basically is mostly for people wanting to watch the performance of the pipeline and see how that works. So these are all the configurations that you have and all the things that you have. And I think I want to address this very quickly, because I think people, if you're coming from a Kafka Connect world, guarantee of delivery is kind of is wishy-washy, like depending on what kind of like connectors you're using. Most of them are good, but in Redpanda Connect, we kind of handles everything in a more unified way, right? So what you get is when you start to get the data, you start in transactions. And this transaction then go into the processor and does, different things like data joins, does some kind of transformations. And then depending on like the different type of inputs, you might have multiple threads. So they all go in there and then like doing things at the simultaneously at the same time to save some, to scale it out, right? So that's kind of what's going on. And then at the very end, when it gets to the endpoints, the endpoints will then send an acknowledgement back to your input saying that, hey, I've got your data, it's received. And then that's how the input would know, and then input would say, okay, now I'm going to move on to the next one, right? So this is how it knows if the data is being delivered or not. So in case that something goes wrong, right? So in case something goes wrong, like the input won't get any acknowledgement. So it will start over and will start from the point where it last receives the acknowledgement. So that's how we guarantee that everything will be delivered. Another thing that we do is we do a little bit of the of making sure that it doesn't fail is when things get backfilled, right? When your endpoints gets really busy, one of the things is that we'll be throttling the inputs. So we'll stop. We'll slowly stop to receive data coming from the inputs, and then until the traffic gets resolved on the output side. Otherwise, we'll incrementally throttle the traffics until it recovers. So that's something that we do, which is making sure that but if it gets really busy, we'll just pause. All the threads are taken, all the memory's out, and all that. We'll just pause the inputs and all that. Right. To run it, how do we run it, right? So RPK Connect is something that we use to run it. So RPK Connect, you can use that, and then you can use the help to actually see like how everything works, right? So this is how you interact with. This is how you get started, right? But if you are new to the technology, you don't know what to do, it is very simple. Like it has a very simple helper. Like I found this very useful, which is the create command. So you can do RPK connect create. So then you can tell like I want to read from a file. I don't want to do anything in the middle. Probably do some mapping maybe. And then I want to maybe send it to a Kafka output, right? So maybe that's what I want to do. And it is going to then give you a template of how everything works, and you can kind of just start there. It just kind of give you a structure. And if you think this is too complex, like this is way too much things to configure, there is a -s version of it, so you get a more like easier way to get started. I think this is like something that you can get started without looking at the without actually looking like into the documentations. A good place to start, right? Another one is lint. Like it basically just lint your file without you running it. So in case that you made some typo, like if we have some typo, let's just do this. RPK connect, and then lint a lint file, and it is going to say, hey, you've got some problem with your YAML file, and let's take a look at it. So what's wrong with this lint file? Well, I mean, oh, I made a typo. I forgot my semicolon. All right. So if I do that again, it will just work, right? So it's just kind of like lint it for you, right? And other thing is run. We'll see a lot of runs today. Oops. Jumping to ahead. And then streams, if you have multiple configuration files, you want to run it all at the same time, you can run like the Redpanda Connect streams, and then with multiple like file names, and then it will just run everything in a single process. That is how you run like multiple of the configuration file all at the same time. So we call it stream mode. And then you can also do some unit testing. Like best practice for developer is always do some kind of best practice testing, right? So how do you do unit testing, right? So now we have a very simple, a configurations. I'm taking it from a Kafka endpoints, and I'm just kind of printing out the content. But in the middle, I have a processor that turns everything into uppercase, right? So I'm going to write a test use case, right? And then it's going to target this particular processor, and then it's going to ask for target the processors and do inputs and then outputs. And in this case, I'm saying that everything will turn into uppercase. And to run it, it's pretty easy. So all you have to do is just do RPK connect test, and then the YAML that you want to test it on, and it's gonna test it, and then you get to see the test result. So if I'm developing, I will probably do a couple of different test use case, just run through it every single time, and just like do some kind of the diligence for making sure you're creating the right project and you're not like, killing your whole system and with all the things that you've done. So that's that. And sometimes people would ask me like, I like how we can configure everything in a YAML file, right? Because this is what you need to do, kind of just like, I want to get something from a CSV file. I'm just doing some kind of processing, and this is the output. This is the configuration file that you have to configure, right? Very simple, very easy. But what happens if I don't want to hard code everything? Like, is it possible? Yeah, of course. So there's a couple of different places that you can kind of like, you can set your configuration and have it retrieve dynamically while running it. So one thing is to environment variable. So environment variable is something that we use all the time. The way to use it is the syntax here, $sign and brackets. And then it also does some kind of like string interpretations and all that, right? So it's like interpretation, meaning that, hey, we have I can kind of look into the payload and then just grab something directly from that. And the payload looks like this. So you've got your metadata in the beginning. This is where you're gonna store like a header, like a metadata header, and then the context is where you're gonna put your payload, right? So this is how you. And this is kind of just showing you how it's how you get the metadata and like all that. So this is all written in the documentations, but I think what I'm doing here is just highlighting highlighting the most important things, right? Next, the Bloblang, right? Bloblang is what we use in order to manipulate, to transform your payload inside the pipeline, right? The way that you use it is you can use different processors, Bloblang processors, mapping processors, and you can also use them in the request map and result map, mostly dealing with mapping. That's when you're using Bloblang, right? And then how it's represented is the final outputs and then the inputs. The output is represented with the roots as the document roots, and then this is kind of the root of your incoming payload, right? So this is how you kind of map them together, right? So if you're saying that if in this particular assignment is saying that, okay, I'm going to turn this value into this field, and this is how I can map everything there, right? So and then you can kind of, and it creates object. It turns things into object automatically. So when it sees it sees a string, it sees a JSON file, it automatically turns that into an object. So you can definitely play around with it, finding the path with it, and just traverse through the documents using the dot, like how you would traverse through a object store, right? And then like some of the other basic stuff is how do you set a variable. This is how you set a variable using let. So if you want to set a variable, temporary variable inside your Bloblang, this is how you set it, and this is how you use it. It definitely supports Boolean operations, arithmetic operations, so you can kind of do some kind of like, equals, comparisons, conditionals, right? Conditionals right here. So it does some kind of conditional, so you can see if this particular type is an array, I'm gonna do such. So this is how you do conditional. And there's another, so this is important, this is gonna be your lab, the match, right? So we will be, so if you have like a more complex conditional, like it needs to be done, you can actually do it here. So you can do, hey, if this particular customer has a loyalty of platinum, then they're gonna get a 30% discount. If they're gold, then 20. If they have nothing else, like not platinum, gold, or silver, then they get 0% discount. This is how it does match. So it goes to this customer object and then look for its loyalty, and then see if it equals. So this one is a conditional phrase, and then it will then map this discount value to the output value here. This is how you can do mapping inside the things, right? And there's like a lot of, like, there's a whole page of methods and functions that Bloblang provides. Just to show you a few example, if I can find it. Where did it go? Oops. If you go to the documentations, and if you go down to the Bloblang session, they have a whole page. Like we have a whole page of like methods and what it supports right here. So you can kind of go through what kind of what we offer like as a methods. So methods are like basically like tiny programs that you run. Functions are the tiny programs that you run. Like basically it's more static. And then you can look at the looking at the message type, message info, message sizes, you know, that kind of stuff with functions. And method is where you can use to, you know, manipulate and change and traverse through arrays. So if you look at the method, if you summarize it, it does a lot of things. So for instance, it allows you to replace all strings. It turns things into strings. It does some kind of timestamp generations. It will help you traverse through arrays. For example, what you're seeing here, apply, you can apply a specific mapping. So mapping is right here, where this maps. So it says apply this mapping, apply this particular format of mapping into this particular object. So you can do that through mapping. You can also traverse through each and every single element in the array with map each. And then if you can check if a certain object or a certain value exists in an array, you can use contains, and then you can merge two different arrays with merge and assign. And then with functions, you can, I think one of the most useful function is content. So I can get the whole payload using the content function. So these are all the very useful ones that we have. And here is a very simple like examples of what we have today, right? So I'm selling airline tickets. In airline tickets, I have an array of different tickets. This one is sold directly by the portal. This one is sold through the partners. So I have two arrays of tickets. And in the tickets, I have departure and destination airport code, right? So from the partner side, I'm getting the airport code only. And from the portal, I'm getting the name of the city and then also the airport code. But actually, I don't want the city names. I just want the airport code. So what happens here is I'm trying to create a map where it does some kind of it goes through and slices through the brackets and then just locate the airport code. And then so this is kind of the mapping that I defined. And then in here, this is the code where I traverse through every single tickets that I have in my object and then replace it with airport code. This is the mapping that I did. And then what I also did is I merged the two tickets into one single array. So as you can see, I do a merge where I merge the tickets with partner tickets. So I'm merging the two things together into a single ticket array. So it's much easier to do that. And I'm also using some kind of like data timestamps and generations of UUID code as well. So these are just some of the methods that you can use in the Bloblang. So hopefully you find this useful. And then exception handling. So exception handling can be handled in the processor side and also the output side, right? Two of them, the drop and the retries, can be applied in both in the processor side and then the output side. I think it's pretty self-explanatory, right? So basically what you need to do is set up a retry, conditional retry, and telling the conditions of when should I stop retrying, right? This is how you set it. And then it's going to, if something goes wrong with this particular processor, it is going to keep retrying until the condition meets. And then this one kind of just, you know, this one you kind of have to do some kind of work on, you know, catching the errors. If there's an error, I'm just gonna drop this payload. So you basically what you need to do is just like delete the payload, and it's called dropped. And then for the what you can do is you can do that in a processor, and here you can do that in both processors and outputs. But you can definitely do a drop in the output as well, right? So that's what you can do. And then next is reject, right? Reject is like doing nothing other than just throwing an error, like I'm done. Like if this doesn't work, I'm just gonna reject it. So you can do that by configuring your outputs. And another one is that letter queue, right? So it is like, if this is more like a fallback method, right? So when you have to set up a fallback, if something goes wrong with this particular output, I'm going to execute that fallback method and make sure that fallback method works, right? So just like the letter queues. All right. we're gonna get started on the first lab, right? The lab is going to be in a lead code style. So I think that's the best way to learn. I don't know, like for me, it's best to be hands-on. So I think that's better. But before you start, I just want to let you know, these are all the resources that you have on hand. So if you go back to a different place tomorrow and then you find problems with you don't know how to do, feel free to hop on our Redpanda community in Slack. There is a channel called Connect. I mean, people are very helpful there. Like people will answer, if you have any questions about it, we're happy to answer questions there. And we also happen to have a Discord. If you are not into Slack, this is too old for me. I like Discord. We have a Discord channel as well. Like you can go there and talk to us. Everything we have people there to help us as well. So the first lab is pretty simple. All you have to do. So this is the link to the lab. What you'll be getting is a very simple interface. So on the left-hand side is your instructions. On the right-hand side, this is a VM that you can work on. So, and then you have your editors. You have your editors right here, and you can kind of take a look at what you can edit, like adding. So this is how you can code. And then I have a separate terminal if you need it, just in case. This is going to be in a lead code style, right? So you're basically given a use case, right? The use case is like, I need to consume data from a file, and with this file, I need to reroute it to different topics. So the first one is a very simple rerouting to multiple different outputs content there, right? So that's that. And yeah, so basically it just gives you a bunch of objectives, what you need to do. But if you're stuck or if you have questions, feel free to raise your hand. I do have the solutions down here, like don't look. I would prefer you to not to look at the solutions before you start, because this is how you learn, right? If you're stuck, feel free to put your hands up. We're happy to help you. But I do definitely recommend you not to look at the solutions before you do, right? So, and then there's two. So if you go to the lab itself, there is going to be 2 labs. Like there's going to be 4 different exercises. I strongly recommend you to. So for lab 1, let's just do the first 2 exercises. And we're going to have another lab later on. Once I cover the more advanced stuff, you have the third one on you have another lab on to do lesson 3 and 4, basically. All right, so let's just go ahead and get started. We have 20 minutes to finish 2 lessons. They're pretty simple if you know what to do. But if you don't, that's fine as well. I would take a look at it. Yeah. How are we doing on the exercise? Like, I'm glad that I'm not hearing any questions. Is that because everybody's focusing on like getting it done? Is it difficult or is it like easy? Oh, I like that you're focusing, Ricardo. Oh, easy for you? Okay, we'll figure out something more challenging for you, Laurie. Were you able to finish all two? Or just like all of them? Yeah. I mean, like if it's for like people that already know about Redpanda Connect, it should be easy. That shouldn't be too hard. Um, yeah, definitely. Like let's figure out something more challenging next time. What would you like to know more about Redpanda Connect? Like, something that you want to learn, let me know because I don't know what you don't know. Does Redpanda Connect have any AI feature for the hackathon? Yes, we do. We'll cover that at the very end, but spoiler alert, yes, we do. So if you go to the processor, section in the documentation, you're gonna see a lot of like AI endpoints. You're gonna see like Olama, you're gonna see OpenAI, you're gonna see like other Vertex and all these different endpoints you can communicate with, you can talk to. You can interact with. So I think one of the example that I did before was I was consuming data and then turn them into embeddings and then turn them back into and then send them to an OpenAI chat. And then did a vector search and then did a OpenAI chat and all that kind of good stuff, right? So definitely do that. I can share with you some of the repository that I did for AI, just kind of get you started on. But we'll definitely cover that at the very end, just kind of getting people to understand Redpanda Connect before we dive into AI. So, yeah, James, like I think it's great for building like streaming AI rag pipelines, right? Like both, I think mostly building pipelines, building inference, I think is like a lot of creative way you can do that. So definitely. And I'm also interested about like, I'm also curious what hackathon like would bring like good ideas that would emerge from the hackathon. This is why we're hosting the hackathon. Like just kind of see how people like with their ideas. I mean, you guys were smarter than me, right? So I was like, if you have better ideas and just show us like what you can do, like, and show us how people utilize this tool to build awesome AI projects, right? So since AI is all the rage today, right? So definitely, and we're chunking out more endpoints. So maybe like how do you bring all these endpoints all together and then having and interacting with AI would be something that's super fun. I still need to think about it since I'm not in the space that long enough, but yeah, definitely I'll take a look at it. So let's see where we are. I know people are focusing, and thanks for answering questions. James and Dave, awesome. It's good to have you here. You will have access to the lab even after this, but it's good to have questions, and I like the interaction here. Like put in chat, like let us know. Yes, I am familiar with AI, Dave. It's like we should like let you show your face, AI Dave, because you look real. Okay. Let me share this. Let me take over the sharing again because I want to go over the answer with you. So let me share my screen. All right. Perfect. All right. So for those of you who is still like working, please, don't worry about it. This lab will be up for a very long time. They'll definitely give you enough time to work on it. So if you don't want to hear about like solutions, just keep your ear shut for like 5 minutes. I will just gonna go over them really quickly. So the first one is getting data from a file, and we're just using the environment variable to get the file name. And then what we're doing next is kind of using mapping or JQ, whatever your preference is. I do have both solutions available in the solution phase. So there is one for JQ, there's one for mapping. I'm just using mapping because I think people would use that mostly. And then it basically just it just does a switch and then kind of just rerouting your message to the right queue, and then you have your data in the right place. So that's the first one, very simple. I know it's easy for people that already know it, but just be mindful. Some people are just getting started. And then for the second one, which is you require to do some kind of mapping, so matching of different conditionals, right? So this one does some kind of conditional. I made it a little bit. I made it more complex, so you can use some kind of like conditionaling here for matching. And here we're just kind of using some mapping through the arrays, right? So just kind of asking you how do you do maps. So you're just traversing through your arrays and then apply your new formattings in with this particular map that you have specified, right? So very simple stuff. And then what happens now is that if the priority is bigger than 3, basically it's all backend services. I'm going to send them into backend error topic. If it's like front-end services, I don't care about front-end errors. So we're just going to send it to HTTP service, which doesn't exist. And then we'll have to kind of do some kind of error handling right here. So we're doing some fallback and then send it to a dead letter queue. That is what we did for the first 2 sessions. If you come back and look at the answers, it wouldn't be that hard. But if you don't know the technology, I mean, this is a good way to get your brain started. But cool. So I will try not to talk for long because I definitely want you to have more time working on the lab itself. So yeah, data enrichment. Data enrichment is something that we need to do all the time for a lot of the pipelines. It's basically going out to another services or another processes and getting more information and then having it attached to your original content, right? So that's kind of what it does. And Redpanda Connect supports it by using an endpoints and processors. So it's between your inputs and between your outputs. You can have it go somewhere else. So to do that, sometimes when you're talking to external services, you want to prepare different headers and your payload to send it over, and then having it reconstruct your outputs based on the return result of your endpoints, and then reconstruct that and send it as output. So to do that, we need to use branch. So branch does that for you. So what happens here is now it will then have a request map for you to assemble your request that goes out to the endpoints, and then a result map for you to kind of restructure your outputs, restructure your data that's going out to the outputs, right? So this is something that you can do in order to get your data right there. But it's like a lot of times we are working with multiple endpoints, so it's very often that we have to talk to multiple different services in order to get our data enriched to the way that we want it to be, right? So that is why we need workflow, right? What is good about workflow is that it is very smart. It will work out a dependency graph. What is a dependency graph, you ask, right? So a lot of times when we're trying to call different service, they're not depending on each other. So the best way we can do it is to do it in parallel. So we want to do the 2, they're not depending on each other, so I want to do them in parallel, right? So the best way is to, if I have like 3 different services I need to call, the first flow A goes to the service A, flow B goes to service B, and they're not depending on each other. The best thing I can do is to call them simultaneously, right? And then Redpanda Connect does filters and then maps out that dependency graph for you, so it knows when to send them out parallelly and when to send them out after each other. So it will figure out that graph for you, so you don't have to do it yourself. And then what happens now is that it will wait. So for flow C, it actually needed 2 results back that came back from both services. So it is going to wait for all the informations came back from the 2 endpoints, and then combine them into and then combine them all together and then call out to flow C, right? And that's kind of how it figures out the dependency mappings and how you can use the workflow to do that. So if you have some kind of need to actually enrich your data by calling multiple endpoints, this is a good way of how to do that. All right, so that's workflow. Another one is caching, right? Caching is important if we want to kind of make it more optimize our to optimize our data pipelines, right? Because a lot of times, if you're kind of say data enrichment, right? If you want to ask for information about the weather is not going to change in like 2 seconds. So you don't have to constantly go back and do the check the weather services all the time, right? So you want to cache them somewhere and have a placeholder in your services. So you're probably going to ask them like every 30 minutes about the updates of the weather. So cache is a great place for you to do that. To configure a cache, all you have to do is configure that cache in your pipeline by specifying a cache resource. And there are different types of caching store like that we support. Of course, you can store that in your local memory; it will work. But we also support having it into a memory database or a key value store, couch database, a document DB, or like a simple databases. I don't know why you want to do that. A file or call storage, right? So I will probably store in memory or in a key value store, but your choice. Now I'll just store that there, so it will then store the things in there. And then what happens now is that when you needed something from the cache, you will be able to access it through a cache processor, right? So depending on the operations you do, it will then be able to get at or delete from the cache, depending on how you configure that, what to do with that, right? So this is kind of like the map I imagine. So first you have to configure the cache, and then you can configure either to interact with the cache directly with the resource, and it will then talk to the actual physical store of that thing. And then the things you can do with caching, you can do dedupes, right? So basically what you can do is you can check if the data exists, or I just keep adding with the same key, and it's constantly going to update what's the latest one. So you have just one copy of that particular informations. And then if you have if you're kind of in batching, so this is kind of goes into the batching and the windowing side of the story. When you have multiple of them, you probably want to just you probably want to do that with the branch, so you can figure out which one you just work with the first one, looking at the keys with that, and then figuring what's inside to do the deduplications for that as well. Another one is a cache enrichment. So basically, is storing data, like what I said about the weather use case, where you're storing temporary informations into a cache. So this is a little bit different from the cache. This one's cached with a D, past tense. So this one does a little bit more compared to the cache. So cache, but basically you just kind of do add, get, update. But this one kind of will. What it will do is will look for, this one does a little bit more. So it will look for if you put data into this cached operator, it's going to look if the data already exists. If it exists, then I'm just going to grab something from the cache store. If it doesn't exist, I am going to go out to the endpoint that I specify here, grab the data back, store that back into the cache. So you're not doing that whole going back and all that mechanism over and specifying on your pipeline. So it's a very simple way to get it done, right? So this is how you can do it. And this one is just configuring that to periodically update your cache. Say, I need to always, recheck the cache data every 10 minutes. And then this is how you're going to do that with TTL equal to 10 minutes. So just different ways you can play around with caching as well. Of course, other than caching temporary data, you can also do data joins. So you can store the data in the cache and then have the cache ready to join with the other requests that you have, and then join them all together. This is also called hydration or data join, whatever you like to call it. This is useful. This is something that you can use in terms of that. All right, buffer. So I think buffer is a little bit unique compared to caching. Caching is I'm just gonna cache that. So buffer is the way that we handle batching and windowing. So basically, instead of one message at a time, we're gonna temporarily store them somewhere. It's called a buffer. and then send them over depending on how you configure that, right? So there's two ways that you can configure buffer. You can use it as a batch buffer, or you can use it as a window buffer. So there's two different types of buffer that you do, right? And remember when I talk about data resiliency, when I talk about it, so every transactions, every inputs that you get from your inputs, every data you get from your inputs will trigger a transaction, right? That a transaction channel for that particular inputs, and then that goes directly to the outputs, right? So that's kind of the mechanism that how Redpanda Connect works. But with buffer, it breaks that transactions, right? So whenever your data gets to the buffer, it gets stored temporarily there. It doesn't get acted yet, but it just stores there, right? It just stores there. Once your data get to the point where this batch is ready to go, whether it's a window, it's a batch, and then it get acknowledged, and then send it over to the outputs, and then that's when it get acknowledged back to the inputs, so that they act based on, you know, that's where we don't have the end-to-end transaction anymore, so it actually stops at the buffer side. So something that you have to look out for when you want to look at the dependencies, but that's kind of how it works. So the way to set up the setup batching is pretty simple, right? So basically for the buffer, all you need to do is just set up your batch policies. Like I want to store every 100, like, or every 10 seconds, and or byte size and all that. Just like depending on your, like what you want for your batching, and then you're just gonna like batch the number that hits this particular configuration, and then you're just gonna send it over to the outputs. That's batching. Another useful use case is windowing, right? So the default windowing that we support in Redpanda Connect is tumbling window. Basically, it's 1, 1, 1. So they'll never overlap, right? So every 5 seconds, I'm going to send this I'm going to send all the data that happens within this 5 seconds over to the other side. That's windowing. So in terms of acknowledgement, every windows goes back at the very end. So once the data that was the very end of that particular window is when the acknowledgement gets sent back, right? So that's when it sends. And then basically just go through every window. And sliding window is another option that we have. So basically it will overlap a little bit. So depending on how you configure, and then there will definitely be overlapping of the data that gets received from the output side. And how do you configure that? It's pretty simple. So basically you have to set up like the system window, like tell the buffer like, hey, you're a buffer for window, system window, and you kind of have to kind of group. You can group them together, like every 5 seconds, I'm going to group this particular message and then all together and then send it over, right? So, and then you definitely have to set the timestamp for getting that particular message. You can do that through sliding window as well, every 10 seconds, and you can do that. So that's windowing. A lot of people would ask like, so does that mean that Redpanda Connect can do like stateful transactions? I don't think so. I think like if you want to do like stateful transactions, I think stateful is a more term that you have to think about, like, you know, we want to keep the state, right? It's not about like simple windowing and getting stuff over. You want to keep things when it fails. And I don't think, so I think that's more of a job of a Flink rather than a simple pipeline that does, you know, every 5 seconds send a window over and all that. This does roll back, it does that well, but I think it just doesn't do to the extent of what people are looking for. So if your turnover stateful is like, I will keep the state of where I was before, yeah, it does stateful. But when your expectation of a stateful services is remembering something that you executed like 3 minutes ago, probably not a good idea. So it depends on like your expectation for stateful pipeline. But in my opinion, that's a stateless pipeline. And then implementing rate limits, right? So we want to make sure that we don't overflood with data spikes. We don't want to overflood our process. And this is where we want to use the rate limits, right? So you can definitely say rate limits. Some inputs already support rate limits, so you can that 100% like, you know, just have it set in the inputs. But if it doesn't support, we have a place for you to set your rate limits. So you can actually store the rate limits either on SQL or in memory, right? And depending on how you share you can definitely have, so if you set your things locally, then you're gonna have like every process will has its own rate limits. If you want to share a rate limit across different processes, you probably want to use some kind of like, external store to store your rate limit numbers. So just be aware of that. All right, lab 2. Let's get started on lab 2. So lab 2 is similar to what we had before, but this time we are going to we're going to interact with 2 different external services. So in the lab itself, make sure you start the 2 HTTP servers. It's in the instructions. Go find it. Like, don't skip that. So you have to start up the two services first in order to have it service your pipeline. So do make sure when you test your pipeline, have those 2 services up and running, right? And by the way, these 2 services are also implemented using Redpanda Connect. Sorry, what I'm thinking. So feel free to take a look at it, right? And the way that I started, I have to. So if you have, here's something that I also learned is that when you're configuring multiple pipelines, and then having them to run in the same streaming mode, you want to make sure that your configuration, which is your cache resource, is stored is in a separate configuration file, and then you have to use -r to let Redpanda Connect know that this is a configuration file. Instead, these are the pipeline files. So just let you know, something like that. Yeah, so go ahead and get started on the second lab, and I will see you in 20 minutes. Hopefully this one's also easy. We'll fix that problem. I think you have to have the consumer groups. I'll let the documentation team know. We'll do it. But good call. Yeah, we'll fix that. The second lab is going to be the same link as the first lab, but it's the 3rd and 4th exercise. Oh, by the way, all these lessons are using the same use case, but they are not, they're not like, related. So they're independent. So if you ever want to go back to look at one of the examples, you can always go back and rerun it. I made it modular, so you don't have to have everything running. Also, like, let me know your feedback on the lab or what is hard for you in terms of like Redpanda Connect. What's the hardest part? Like, is it the Bloblang or is it configuring? What is like, what do you find the most difficult thing about Redpanda Connect? How do we clarify that for you? Would love to know that because I think it's worth maybe another masterclass or not, like depending on like what you're asking for, right? I love to kind of learn what you want to know about Redpanda Connect. Yeah, I agree. The syntax is probably like I also struggle a little bit because I do understand when I read it, but it's just like when you're writing it, it's hard to remember what that was. I have to constantly go back and look at the documentations and figure out why. Maybe we should build an AI tool that builds it for me. That would be fun. That's accurate. Like I think I did try like see if OpenAI does that for me, but I don't think it does a great job interpreting it. Like especially getting the syntax right. Maybe we should like just build one. Who knows? That would be a fun hackathon project to do. Yeah, Bloblang AI. That would be cool. Maybe we should build that into like the console, like a place where like I want to build a pipeline and just like express it as a natural language, and then we'll just build it even better than the studio because studio you can still have to drag and drop, and this one's like generated for you. I think we're beyond the drag and drop non-code like environment, like non-code, low code thing with LangGraph. Yes, that would be awesome. Embedded LMs containing a console. I don't know. Like it's I think it's gonna be super expensive to run an LLM like in a console, right? Yeah, how does that work? Like I know it's pretty expensive to run one command, even like if you send it over to OpenAI. Like I think one request would cost you about like 0.15 cents, right? Or $0.515. I don't know, like I think it's super expensive. So we'll have to figure out how to do that. Um, but yeah, I mean like maybe with the smaller model, that will probably work with like less tokens. Yeah, more documentations and maybe more examples on the documentations and teaching people like how do you do that with different examples might be helpful. That's a good suggestion. Yeah. A local model. Yeah, but then we have to ask people to run to install local models instead of like running it, hosting it somewhere else. Auto completion. Yeah, auto completion might be good. I didn't, so I have Copilot installed in my VS Code. So it does a little bit of auto completion, but I do think it's pretty stupid. Like it doesn't really work that way. So I have to do a couple of different ones in my repository in order for the autopilot, for the Copilot to learn how to do like auto completion. But I think you can actually do that because now like with my VS Code, it does some kind of auto completion for me already. Like if I have it like enabled, Now you know my secret. Like, how do you work without Copilot? I'm too old. Yeah, sovereign AI. I think sovereign AI is like the next thing. Like, how do you run your local models locally without doing everything like on the vendor side, like running your own small models and all that. Maybe a bunch of examples of, yeah, maybe we can do that. I think we just need more time to build more content around Redpanda Connect and LLMs and all that. We just need more time. If like maybe like from the hackathon, like if people would love, since they'll be sharing a lot of the repository, we might have all that like in one place, so people can also use that. Will be useful as well, right? A complete course on Redpanda University. Yeah, we're working on that. We actually, so we are actually working on a course for Redpanda Connect University. I think it's gonna take 2 courses to complete everything. So I think the first one will be mostly very similar to what I'm doing here, but I'm doing it in a LeetCode style where I think university probably not gonna do that. I think it will be more like guided journey. And the second one will be more like deep dive. So we are planning on getting at least 2 courses out for Redpanda Connect. That's planned. So Evan, what you're saying is you lose the transaction features in all input technology. So if the buffer fills up, what is going to happen is it's going to drop some of the windows depending on like where you are. So if you're doing some windowing, it is going to drop like the expired windows. So it's not going to guarantee all the deliveries of your data. You might lose some windows in terms of like if you have a very packed, very full buffer, it will lose that. So that's what I meant by losing it. So, and the acknowledgement actually goes back. Oh yeah, like I think David's already answered your questions, right? So yeah. Depending on how you configure your buffer. If it's like memory, then like if it's filled, then we're gonna lose some of the early on content as well. So that's what I'm worrying about. Like in calling it stateful and guaranteed deliveries and all that, it's not guaranteed if you're doing buffers. But you don't have to worry about it if you're not doing buffers or batching or windows, it will just go directly, and the behavior will be very constant. So you're not constantly like guessing if this one's already delivered or not, like what you had before. But now it's like it's more like a more unified behavior. It's when you have buffers, then you're gonna have some kind of way of like dealing with lost windows or lost batches, or it will stop all the traffics when the buffer is also full. So you're not gonna your entire pipeline will be in pause if your buffer is full until it resolves the buffer. Then it will slowly come back to life. But other than that, it's gonna be like it will go into a pause. And for those of you who wants to learn like the latest and greatest about AI and what we're pushing, I'm following like very closely to what our engineerings are pushing out lately. But I mean, they're just like chunking out a lot of content, like a lot. So even I have like hard time like following every single thing that they do. So what the best you can do about what AI and what we're doing with AI is that you can like subscribe to our YouTube channel. We have an engineering engineering corner. This is where we put all the engineering demos and engineering stuff in that particular playlist. And that's why we don't do a lot of like editing for that kind of materials. Basically, what the engineer did, we just kind of presented in that particular video, and you get to see like what they're doing. So they would kind of do. So they're not gonna do like an end-to-end, holistic, a huge demo, but they will show you how each and every feature works. And I think it's a very good information if you're kind of wanting to learn the latest and greatest and what you can do. So if you want to learn about like how do you add schema to your AI outputs, just making sure that it's always going to give you like this structure in a structured way of how you want it to be. There is a video on that as well. Yeah, so definitely, I would definitely look at the YouTube channel, Engineering Corner, the playlist. I would definitely look at it. And yeah, and then about schema registry. So if in the university course, processing streaming, I believe it's called streaming processing course. I think that course covers how do you do schema registry with Redpanda Connect. I know because I did that. So I think you can kind of go back to that university course and take a look at how it's done. It does cover like how do you use schema registries with that, and how do you do, I think that one's Avril, not Protobuf, but I could be wrong, I forgot, it's been a while. But I think that one's Avril, so you can take a look at how it's done. But yeah, definitely that's a good content for next time, I guess, if a masterclass. Yeah, Dave, I think you're right. You can always break up your pipelines. Like I think also like design your content with like event-driven architectures and all that can be also like useful. Like just breaking like middle points, like, and then having that middle points allows you to broadcast and having more parallel working and all that more. I think that will be a good design as well, right? So I am going to take over sharing. All right. I hope you all are super focused and like knowing what to do. But here is a quick explanations of what's going on in the third and the fourth lab. So the lab, the first one is very simple. Like it's basically asking you to go out to two different services, HTTP services. So basically just putting a workflow with two different branches, geolocations and error count. The error count is not doing anything. I built it because I needed a second endpoint to call, but it does nothing. The meat is here is the geolocations. So you gotta reassemble your request so that it will take and then it will just read and it will identify the IP addresses and all that. And then yeah, so that's what you need to do. And then also we're using the cache. So we're trying to cache geolocation information based on the IP address of this person. So I have a cache resource, which has an hour of retention TTL. So basically it will just update every hour about this person's IP address and geolocations. All right, so that's what it does. It will just branch out to do things in parallel and come back. I think when you started, they in the beginning, it shows a dependency graph in the log as well. You can kind of take a look at it. That's the first one. The second lab is again a very simple one as well. This one just asks you to do some kind of windowing. So we're using a tumbling window, a default tumbling window, where every 3 seconds we're going to aggregate all the errors together. And I think the things you have to do here is to do some kind of like aggregations for going through the arrays of inputs. So I'm just looking at the unique number of counts. So here are some of the method I use from all the message I'm getting. Anything that has, priority 1, that will get processed and then added as priority 1. So I'm just kind of counting that, aggregating summary of like the number of errors every 3 seconds and coming from which source system, right? So it's a very simple aggregation. Here's something that's important, that if you're trying to aggregate everything together, you probably just want to keep one message out. Like the way that I process is going to process multiple times, but you just want to keep one. So we're deleting the rest of it. We just want to keep the first content. That's kind of it. So that's the end of all the labs. I hope you've did that. Yeah. Everything's easy, right? If you're struggling, that's fine as well, because I do struggle a little bit. If I can imagine I'm struggling a little bit. If you don't know what to do. Is there a case where processing task is so complicated that can't probably be represented in YAML? Yeah, of course. There will always be things like that. So there's a couple of ways you can do it. You can take a look at Dave's repository. So in his case, he's using Python, so you will be able to do more complex processing in that. But you have to be careful about the libraries that you're pulling in, Python libraries that you're using. Another way that you can build it is you can actually write your own binary, your own Redpanda Connect. It's basically a Golang application. It has a good SDK that tells you what to do, inputs, and there's a processor, there's an output channels and all that. You can kind of build your own connector as well. Redpanda Connect is on the MIT license, so you will be able to kind of do it yourself and then kind of put that in your own production on your own risk, at your own risk, because you built it. But yeah, and we're happy to have you also contribute to the community. If you think that your connector is awesome, everybody should know about it. Love to see your contribution. I'm pretty sure Ash will love it, because he's working on a lot of connectors right now. So yeah, I think he will, happy to have your contribution there as well. All right, so AI use cases. Oh, so before we dive into AI use cases, these are some of the FAQs. I think what people often ask me, like one of the FAQs I hear from the community is like, can I only have one input? Can I also get data messages from multiple inputs? Yes, you can. You have to use broker. There is a broker processors in the inputs that you have to configure, so you can configure multiple inputs. So you can do that. So if your output target starts, so if your output starts to fill up, it's getting too busy, it's blocking the traffic, Redpanda Connect will gracefully was the words I was looking for, gracefully terminate the process or shut down or gracefully stop consuming data, and then it will come back up when it's the blocking situation resolves, right? And yeah, so Redpanda Connect provides metrics that allows you to connect for Prometheus, so you can kind of see the performance of how each Redpanda Connect pipeline works. Tracing, you can definitely map it to, you can definitely set your Jaeger, have the tracing events sent to Jaeger, so you can kind of see how everything works. From my perspective, I think a lot of us are working with Kafka, and it's more like asynchronous. So it's actually no point of figuring out the tracing of everything. But yeah, I think maybe we need a class to talk about how to do that, to view it. But I think that personally, I think HTTP endpoints is probably the best to view the steps for each one. And to run it in Kubernetes, you can definitely package everything into a Docker image and then have it deployed into Kubernetes, right? And there is a link to the sample Docker file. So you can use that. It will already have Redpanda Connect in it. So all you have to do is just provide a Connect YAML and it will just work, right? So just some of the things that we have. Now, AI. We have what? 23 minutes left, and we want to talk about AI. But I think there's not much to cover other than, yeah, we have AI endpoints, and then there's a lot of them. So if you go to the documentations we have today, where are they? So if you go to the components, if you go to the processors, and you're gonna see a lot of like AI endpoints. So this one, Ollama, so you can, what's going on with that? Yeah, so they're here. So here you see a lot of like OpenAI and Ollama. So I think you can either like run the models locally with Ollama, just having it up running, and then having it to, and then you can use this endpoint. So the endpoint is basically very self-explanatory. So for Ollama, you probably want to pull in the model before you start using it, like obviously, right? And then you can just specify like how you want to run it. And then there's other things you can do with OpenAI. You can kind of like put in what you can do with OpenAI. OpenAI translations, like these are all the things you can use. So basically, you just have to specify the address for that, and that's all you need to do. And it will be able to interact with your AI models, right? And so the most commonly used models are, I think it's mostly C, things like embedding is mostly what we use. And then you can use other things. Yes, we do have integration with Bedrock and then also Vertex. So depending on like your favorite providers, you can definitely use that, right? So yeah. Oh, by the way, I did a demo before. I put the Redpanda Connect in the in Lambda. So I was the kind of like I package everything into Lambda, and then and then having it triggered by events coming from Redpanda, and then that sends that triggers a output to Bedrock and then comes back. So you can also do that. That's another way to interact with AWS services if you want to. So the way that you kind of look at how everything works for Redpanda Connect is that when you configure everything, and then you can containerize it or run it locally as a single process in your computer, and then it will talk to multiple models, like which one you ever prefer, right? And it doesn't only just talk to the model, it also interacts with different vector databases. So pgvector, Pinecone, and any other Neo, I think Neon as well. I think it does do that as well. It's basic Postgres. So like you can actually have it interact with that, so you can build your inference use case based on that as well, right? So you can definitely do that, something that you can think about. So all the endpoints are right here. So the output endpoint, say Pinecone, is right here. And then we can also talk to OpenSearch if you're like AWS like thing, right? You can also use OpenSearch. So you can write to different vector databases and all that right here. So that's that, right? So let's go over a use case. Why don't we do that? So what I have here is a use case. This is more like a legal use case. I know a lot of people in legal, there's a lot of documents, a lot of past case, and we have paralegals trying to figure it out for the attorneys, right? And the biggest problem with that is that it's all unstructured data, so it's really hard to search for them. So the easiest way is how do we make it easy for people to interact with the models, right? How do we do that? So how do we search for the more relevant use case, and then maybe turn that into something that the legal firm can use, right? So first of all, what we can do is we can take the documents. So here is a bunch of documents. These are all cases that's been kind of imagined by me, right? Like this all like cases. Now what I'm going to do is I need to summarize it. And the reason why I'm summarizing is because I think you want to do some chunking. And then there's always an optimized way of chunking and making sure how do you tokenizing and making it like more effective for searching. So that's why I send it to OpenAI to summarize data so that so I don't have to chunk it. So basically I just like made it to smaller so it's easier to search and all that. Summarizing it and then putting into topics. So this is one way of like building a pipeline. So this is my breakpoint for the pipelines. Then what happens is I build another pipeline that goes out and turns the content into embeddings. How do I do that? So I interact with another OpenAI pipeline, another OpenAI services, build another pipeline that talks to OpenAI, and then get the embeddings, and then store them into Pinecone. That's like a vector database uses. So then I can like use applications that, that just talk directly to, I can just use that to search for data. That's my use case. And that's what I built. So if you look at, so this is a empty like Pinecone. I'm trying to get all my data over to Pinecone, right? So what I can do here is I created two different pipelines. The first pipeline, very simple use case, is I then take data from a directory, reading all the use cases. I turn them, I send them over to OpenAI and ask them to summarize the use cases for me. And then I just pump in all the use cases with the content summaries. And then it's going to send me the data back. I'm saying that, okay, so put this in a summary and then send them over to my Redpanda. So that's what I was trying to do, right? So I will then now run my pipeline. It is now going to go through and then send everything over to OpenAI and does the summary for me. So you can see that it now summarized my case into something that's more readable. And now everything is in my legal cases. Now it's all over here. And it has the original text and then also a summarized version of it. Now, how do I turn this into embedding and then store them into a vector database? So this is the second pipeline that I built, which is now I'm going to convert everything into embeddings. So I'm going to read every single one of the summarized cases from my topics and then summarizing all of them and then sending all of them to OpenAI embedding, which turns them into OpenAI embeddings and then store them into Pinecone. That's it, right? So I'm going to go off and then run this really cool pipeline. So you see like all the vector like turns into, right? And once it's done, I can go back to my Pinecone databases, the index that I created, and look at the records again and see, right? Let me refresh that again. Takes time for it to upload. Here, see, like the data are all available here, and this is the actual vector that was turned into, right? So this is what it is, and yeah, so then I can go ahead and start my. So here, what I did is I kind of just used I just used a very simple like LangChain applications. Like you can also write that in a Redpanda Connect pipeline. Like it depends on what you do, but I just did a LangChain. So the LangChain is pretty much here. Just kind of went up and query the Pinecone databases and do a RAG use case, kind of query everything and then just send it to OpenAI. And then I can start my applications, right? And then I can say, any scam use case you can show me. And then it's gonna go off and then download, get everything, and then send it over to OpenAI, and then come back with an answer. It is going to take some time, but it will then. See, like it will show me like, oh, there's two different use cases about scams, right? So now it goes back and retrieve the right use case for me, right? So that is what's going on with OpenAI. Of course, if you need inspirations, this is my view of what the future will look like for AI. This is super confusing, I know, but like my view is that this is all traditional. Like right here, this is all traditional. Like our streaming data goes into data lake, and then they get a lot of like traditional pipeline that generates data into data sets, and then you build your models right here. That's traditional. But what happens here is now you need somebody to do the work to transform your unstructured data over into vector database, and they need to turn into embeddings. This is where we can like do that with Redpanda Connect, where it will turn everything into embeddings and then save them into vector database. Something that you can do here. Also on the inference part is also equally interesting because all the data you're getting in from different applications, eventually hopefully they will be ending up in an event-driven architecture where everything is a service. I think, in my opinion, LLM is going to be one of the service that you call in the future, but it is not going to be all of them, right? So it will be part of the services that you'll be using, right? And it will then talk to, a large language model, and it will also do some kind of reg inquiries. So this is where Redpanda Connect can help you glue everything together by talking to LLMs, interacting with embedding models, and then providing answers back to your users. So that's kind of where I see everything is. Of course, then you're gonna get like your services doing some data enrichment with Redpanda Connect as well, right? So that's where you get that there. So if you're building something fun for hackathon, this is where I kind of see like, how do I build something that's useful, meaningful in this kind of this area, right? And last but not least, last fall, I hope you're still here. How technical do you think this session is? Is it too easy? Is it too hard? I need something that's more difficult. If you think you need something more difficult, definitely let me know. If you want something that's easy, also let me know. And then also let me know like what kind of things you want to see. The format of how we're going to deliver that. I'd love to hear your thoughts and feedback. Do that in Slack, in our Slack community, or on Discord. Love to hear them, right? Yeah, so just gonna give it a couple of different seconds, and then we have all right, another reminder, hackathon. Everybody go and sign up for the hackathon. Please do that. We need more people participating. It's good price. It takes me a lot of time to organize this hackathon. So please go over and sign up for a hackathon. Or, if you know anybody who is interested, or who anybody in a university or student that might be interested, definitely like send it out to them. Like this is really fun. And then like you've just learned about Redpanda Connect, and maybe they can learn about it. Like this is a good way of like getting into the industry, letting them learn like this is the first project. It's not like super difficult. You can just assemble things together. Good things to put that foot in the door, right? Just just like send it over to somebody that you know, that you think that would be benefit from this as well. Definitely share that with them. So with that, we are at the Q&A session. Do we have any Q&A? I think we addressed most of them already. Right? Do we have any Q&As? Do we have any questions? Let me take a look at it. If not, I think we will give you 9 minutes back. I should have given you more time on the lab. But yeah, but you have more of the time. Okay, by the way, the lab itself, if you are those people, I mean, I know there's a lot of people that, that don't like an environment. So everything, where did I put it? Here. In my repository, in the Master Connect repository here, Elizabeth, can you share this with the folks? So this one, I have all the instructions, copy and paste here. So if you want to run it locally in your environment, if you want to go ahead and set up RPK and Redpanda Connect, feel free to do so. I think it's awesome for you to install that locally in your laptop instead of having it in a restricted or in a controlled environment. Feel free to hack along and then have it fun for it. But you do want to make sure you installed your RPK. So these are all the instructions and link to the link to like the documentations of how you want to install that too. And another one I did, I think was fun. So there is a gaming demo that I did. So there's a YouTube video that I did for that. So you can go ahead and watch it. But basically I made a demo on using Redpanda Connect strictly to create immersive gaming environment. So people uses where is it? Oh, right here. Here are my, this is like the reg use case I built for using Redpanda Connect. So if you look at it, it's nothing crazy. Oh, by the way, I'm using Llama in this case. And I'm just kind of going to like a local Postgres with PG vector already installed. And then I'm just kind of query about like the fantasy world that I built. And then it will just, the character will then respond as a, for that as well, right? So that. What else? What else do I want to tell you? Do you all have any questions? Oh no, we'll just give you like what, 5 minutes back? Well, cool. All right then. Thank you very much for joining today. I hope you learned something. And yeah, let me know your feedback in our Slack. Yeah, so I will see you next time in the masterclass.